Hello, it is Wednesday, March 10th, and it's time to check our bell work. You should have these all done, just making corrections as we go. This first set, I just ask you to solve. Write your answers as mixed or whole numbers in simplest form whenever you can. So here we go, a nice little review of multiplication and division. For this first one, you need to change 2 4/5 into an improper fraction. We do that by taking the denominator times the whole number, 5 times 2 is 10, and adding our numerator, which is 14/5. And now we should ask ourselves, can I cross simplify anywhere? Because I don't want to do 6 times 14. I don't have to. Nope, because I can divide each of those by 7. 7 divided by 7 is 1, and 14 divided by 7 is 2. So now, instead of doing 6 times 14, I can do 6 times 2, which is 12, and 1 times 5 is 5. This is improper, so it says to write it as a mixed number whenever I can, and I can. 5 times 2 gets me closest to 12. And then there are 2 left over out of 5. The old trusty denominator never changes. It's nice to have those things in our life, isn't it, that don't change? Okay, next one. I see a whole number here, so I'm gonna put a 1 underneath it, and then I'm gonna ask myself, can I cross simplify? With 1 and 3, I can't, but with 15 and 10, I actually can. I know you can't divide them both by 10, but you can divide them both by 5. If a number ends in 5 or a number ends in 0, it's divisible by 5. So 15 divided by 5 is 3, and 10 divided by 5 is 2. So we're left with 3 times 3, which is 9, and 1 times 2, which is 2. 2 times 4 gets me closest to 9. 2 times 4 is 8, and there's 1 left over to get to that 9 out of 2, so 4.5. Number 3, 4 sevens times 4 sevens. I know the digits directly across from one another are the same, but we need to have diagonal, because when you simplify a fraction, aren't you dividing into the numerator and the denominator? Yeah, so when we cross simplify, it has to be the diagonal, so we have 1 from the numerator and 1 from the denominator. So we can't cross simplify. 4 times 4 is 16, 7 times 7 is 49, and that'll be it for that one. All right, now we have some division. 10 divided by 7. Now you may be at the point where you're just like, well, 10 divided by 7, that means 10 over 7. That's okay with me. Or you can look at this as, oh, I'm gonna multiply by the inverse, which 7 can be written as 7 over 1, so I can multiply that by 1/7. So opposite operation, inverse of that number that follows. And if you have 1/7 10 times, yes, you have 10 sevens. This is improper though. So 7 will go into 10 one time, and there's 3 left over to get to that 10, 7, 8, 9, 10. And my denominator doesn't change. For number 5, 1/9 divided by 3, I would take 1/9 and I can multiply that by 1/3, because this would be 3 over 1. So if I'm going to take the opposite operation, I'm going to take the opposite of that 3 over 1. I end up with 1 over 27, which is already simplest form. For number 6, 8 divided by 1/8, I can do the opposite operation and then take the inverse of 1/8, which is 8 over 1, or just 8. So 8 divided by 1/8 is 64. And I know it might seem kind of strange, but think about it. Like I'm asking you how many 1/8 there are in 8. Well, there would be 8 1/8 in just 1. So in 8, there would be 8 times 8. Remember that visual model. Don't forget the visual models. Once we learn all these little tricks to solve it, remember you can always go back to that picture. Pictures totally make sense. All right, the next section says to write and solve an equation for each. So you have to do both. Not just an answer. We want to write an equation and solve it. Write your answers as mixed or whole numbers in simplest form whenever possible. Number 7, Nancy needs 2 2/3 feet of thread to finish a pillow she was making. If she has 2 times the amount of thread that she needs, what is the length of the thread that she has? So she needs 2 2/3 feet. She has 2 times the amount that she needs. And the amount she needs is 2 2/3. So if she has 2 times what she needs, that would mean 2 times 2 2/3. All right, so let's solve this. I'm going to change that 2 to 2 over 1. And I'm going to change 2 2/3 to an improper fraction. 3 times 2 is 6, and 6 plus 2 is 8/3. Can't cross simplify anywhere. So 2 times 8 is 16. 3 times 1 is 3. Okay, 3 times what gets me closest to 16? 3 times 5 is 15. There's a 1 left to get to that 16. My denominator doesn't change. So it is 5 1/3 feet. That's how long the thread is that she has. And if you think about it, like if you have 2 2/3 twice, 2 and 2 would make 4, and 2/3 and 2/3 would make 4/3. So I could pull 3/3 from that and have 5, and there'd be 1/3 left over. So like, yeah, this answer makes sense. That's a question you should always ask yourself. All right, a chef had 7 potatoes. How many bowls of mashed potatoes could he make if each bowl used 1/5 of a potato? So how many bowls could he make if each bowl used 1/5 of a potato? So what I'm asking you is, how many 1/5s are there in 7? And if I want to know how many 1/5s there are in 7, that means division, right? And if you think about it, if he has 7 potatoes and each bowl only uses 1/5 of that, shouldn't I get an answer that's more than 7? Yeah. So what do I do with 7 and 1/5? 7 and a number that is less than 1 if I want to get a greater result? Well, I know if I multiply by something that's lower than 1, I'm going to get a lesser result. So I would have to divide. So no matter how you rationalize through it, it's division. How many 1/5s are there in 7? 7 is the amount that you start with. You can't change that. So in order to do 7 divided by 1/5, I can use the inverse, right? 7 times, and 1/5 would be 5 over 1 is what I want to multiply by. And 5 over 1 is the same as 5. So 35 bowls. And let's ask ourselves if this makes sense. If you have 7 potatoes and you can make a bowl with just 1/5 of that, wouldn't it take, like, couldn't I make 5 bowls with 1 potato? So if I could make 5 bowls with 1 potato, then with 7 potatoes, I would make 7 times 5. Yes, it makes sense. All right, last one. Marilyn has 3 watermelons. This is your typical math story problem, right? There's always like watermelons or cantaloupes or some crazy number. I guess 3 is not too crazy. All right, I should have made it a little bit more crazy. That's kind of fun sometimes. But anyway, Marilyn has 3 watermelons that she cuts into halves and gives to her neighbors. How many neighbors will get a half a size piece of watermelon? Okay, so she's starting off with 3 watermelons, right? And then she takes each of those watermelons and she cuts them in half. And we want to know how many neighbors will get a half a size piece of watermelon. Maybe you're like, well, I don't know what to do. I'm just going to draw it. Well, if she has 3 watermelons and she cuts them into halves, and we want to know how many neighbors are going to get a half a size piece, well, 1, 2, 3, 4, 5, 6, right? So we already know our answer is 6. What can I do with 3 and 1/2 to get 6? I want to do something with the 3 and the 1/2 that will get me a greater result than what I start with. So would you multiply 3 by 1/2? If you multiply by a number less than 1, do you get a greater result? No. So we're taking 3, and I want to know how many half-size pieces are in 3. This is a division equation, and yes, you have to write that because the direction said to write and solve an equation for each. Maybe you just jump straight to 3 times 2. Either one of those is fine. Those are both equations. 3 times 2 is 6. So 6 neighbors. And you are set with your bell work for today. I hope you have a fantastic rest of your day. See you soon.